Welcome, class, to Advanced Aircraft Systems. I'm your instructor. Today's lecture will be lecture number 9, covering the hydraulic systems on the CRJ 700. The hydraulic systems, once again, here we go. CRJ 700. The hydraulic system is designed to provide primary and backup sources of hydraulic power for flight controls, spoilers, landing gear, and brakes. Extremely important system on this aircraft. It relies heavily on its hydraulic systems for various multiple systems. So what we have here are hydraulic systems number 1, 2, and 3. I'll just label them. There's number 1 and number 2, and then of course number 3. And we'll notice that we have a few different things on each system as we get more involved in the system itself. So fairly simple, right? Not too complicated yet. So each system is powered by 2 pumps. Each pump in each system is referred to as pump A or pump B. A pumps are considered to be the primary pump for each individual system, and B pumps are considered to be the backup. So you remember that because B stands for backup. So hydraulic system number 1 is powered by the left engine hydraulic left engine pump, which is what we call the EDP 1A. Okay, so that means simply that it's an engine-driven pump. The number 1 refers to the system that is the hydraulic system number 1, and the A stands for the idea that it's the primary pump for that system. The backup pump is an AC, alternating current, electrical pump, and we refer to that as AC motor pump 1B. So it's the number 1 system. It's B, stands for backup. So the backup pump is AC mechanical pump. Hydraulic system number 2 is powered by the right engine, the EDP 2A, very similar to EDP 1A. The backup is an AC electrical pump that we call it the AC MP2B. So there is a little bit of logic in their naming if you get used to it. Hydraulic system number 3 is powered by 2 AC pumps. The primary pump is the AC MP3A, and the backup, of course, is 3B. So let's just take a quick look at this. So here we have system number 1. And we have an engine-driven pump right here. It says EDP 1A. So this means this is the engine-driven pump. And you'll notice it's shown in green on this schematic because what they're saying is that the engine is going to be the primary driver of that pump. That would be engine number 1 or the left engine. Likewise, in system number 2, we'll just label this as system number 1. And this is 2. Of course, this would be 3. And again, we have the same situation over here where the EDP number 2A is driven by the engine, and that's the primary pump, of course. Then, of course, system number 3 has 2 pumps, 2 electrical pumps. And these 2 electrical pumps, one is primary, one is the backup. Primary designated by the A right there. So this is the primary pump, and again shown in green. So very important that we have 3 systems for redundancy on this aircraft. All right, source of hydraulic pump power, ED Number one, ED pump is driven by the engine. We just talked about this. And number two is by the engine number two. Normally, hydraulic number three is driven by an AC, alternating current, number 3A. However, in the event of a total AC electrical failure, the ADG will provide power to the ACMP3. So what we're saying here, pretty straightforward. As we talked about, this is your primary pump on the system number three. This is your backup pump, and the backup pump is going to operate if you have a total electrical failure, which would, of course, take this pump out, and it would take this pump out, and it would take this pump out. At that point in time, those pumps would no longer be available to you. The ADG, the air-driven generator, would then provide power to this number 3B pump. So that's how that works. Just don't get confused that the ADG drives the number 3A pump. It does not. It drives the 3B pump. That's why they call it a backup. Okay, exam question. Here's what we want to know, and I haven't even given you this question yet. I'm going to let you go ahead and research this a little bit on your own. How do you research it? Well, you go back to the hydraulic modules in your AeroSim pack and review, of course, the hydraulic system, and it will go through and give you this answer. This could very possibly be an exam question. So the question would be, from what bus, in other words, electrical bus, does the AC, alternating current manual pump, mechanical pump, 2B, get electrical power? So that's 2B. So that's on engine number two, right? So where does it get its electrical power? I want you to research that a little bit. Very possibly going to be on the exam. Engine fire shutoff valve. All right. In the schematic, in the event of an engine fire, you would certainly not want hydraulic fluid just being poured into the cowling. Although in most cases, hydraulic fluid is not highly flammable. Still, it's just one of the valves that would close to shut the fluid off to that engine. So in the event of an engine fire, hydraulic flow to either system number one or system number two. We're not talking about three because it's not an engine driven, does not have an engine driven pump on it. The valve can be shut off for the respective engine. System number three does not have an associated fire shutoff valve. So where is the fire shutoff valve? Real quickly, it is right there. So in each system, for the engine-driven hydraulic systems, 1 and 2, you would have a shutoff valve in the event of an engine fire. So you can imagine that fluid would be moving in that direction, and fluid for number 2 in this direction, and it circulates throughout and comes up and powers these items. Well, you would shut this fluid off so that it did not enter into the engine cowling area. That's just one of the things you do when you press the fire button. You do several things, and one of them is shutting off the hydraulic system. Think of it as being the acronym BATFISH. We'll probably get involved in that here just a little later. So, as we've talked about, it's really neat with this airplane because you can pull up all the schematics that are necessary for all the major systems anyway, right off your synoptic panel selector. So you can go that where it says hydraulics abbreviated, you can push that button, and then on ICAS number 2 panel, you would get this particular indication as to what is being powered by each of the systems. And again, just like the schematics were showing us, this is system number 1 and 2 and 3. So where's the engines at? Of course, located right here. That's the 1A pump. This is the 2A pump. And right here shows an electrical pump. That's your 3A primary electrical pump for system 3. There's your backup, and then there's the backup for system number 2. And if you take a look here, you can see it's providing 3,000 PSI to each one of these systems. And what's neat about this is, if you take a look at this, you'll find out, I think we showed you this in another video, but you'll see that system number 1 provides power to the rudder, elevator, and left aileron. System number 2 provides the same power to the rudder, elevator, and the right aileron, whereas system number 3 provides power to the left and right aileron, as well as the elevator and rudder. So a lot of redundancy here, and just keep that in mind where the power is coming from. Then you have outboard spoilers and on number 1, and inboard ground spoilers on number 3, and inboard spoileron on number 2. So you can take a look at these and figure out what's powering what throughout your flight systems. Okay. Then you have a few other things like left reverser, thrust reverser on the left engine, and right reverse thrust on the right engine. And off of hydraulic systems 1 and 2, there is no thrust reverser hydraulic power coming from system number 3. So by selecting the hydraulic synoptics page, primary components and system information can be viewed that include reservoirs, shutoff valves, electric pumps, system pressure, temperature and quantity, and system distribution. So we can sit here and also look up here. We'll get rid of some of this drawings. Up here, as a review, there's your temperature of the hydraulic fluid in each of the reservoirs. This, of course, being a reservoir. And likewise, 3 and 2. Then you can see what the fluid level is in each tank or each reservoir. So system number 1 shows 60%. System number 2 shows, or 2 shows 60%, and number 3 shows 75%. Other than that, pretty straightforward. It does show in green outlines which pump is providing the power. And so all your standby pumps, 1B, 2B, and 3B, are just standing by, ready to jump in when necessary to pick up any loss of pressure. Reservoir and accumulators. So this is kind of important. Each of the 3 hydraulic systems has its own dedicated hydraulic reservoir. The reservoirs are sealed and pressurized. Items on system number 3 have the largest displacement demand, and thus has the largest reservoir capacity of the 3 systems. Accumulators are located within each of the 3 systems. Accumulators are stored pressure so that a given system can provide instantaneous pressure when an actuator is operated. Accumulators also dampen sharp changes in system pressure. In certain cases, accumulators act as a one-time backup to hydraulic systems and devices such as brakes in the event of power loss. So let's take a look here real quick how this works. So here we have a reservoir, system number 1 reservoir. And then we have system number 2. And as you can see, it is system number 3 is depicted as the largest reservoir. Do I really care what the volume is? Not as a pilot, there's not much I can do about it, but I would like to know how full that reservoir is, if it's 60% full or 75% full. So we get that going back to our synoptics pages and taking a look at the hydraulic system in the aircraft directly. So The other thing that's important is we have these accumulators right here. And so what do accumulators do? They dampen the sharp changes in pressure uh, in the hydraulic system. And also, if you'll notice that we have on this, we have up here in this system, we have right and left inboard brakes on system number 3, and we have right and left outboard brakes on system number 2. Now, why is that important to know? Because we have an accumulator here and an accumulator there. So let's say we were to lose systems number 3 and number 2. Boom, they're gone. We're in flight, and we'd like to come back and be able to land the aircraft, and we'd like to have some brakes available to us. So if the accumulators are working properly, it's basically storing hydraulic pressure for us. So once we touch down, we can go ahead and apply brake pressure. That will add braking to the brake pads will actually close and allow the wheels to come to a stop. The caveat on that is when you are using nothing but accumulator pressure for braking, apply a steady brake pressure. Do not pump the brakes. One steady amount of pressure is what you need to apply here. If you pump the brakes, each time you pump the brakes, the brake system resets, takes another look at it, and then you pump it again, and it keeps using up fluid each time you pump the brakes. Well, you don't have that much fluid in these accumulators. So one steady, continuous pressure on the brakes is what you want to use in this kind of case. So don't pump them, steady pressure when you're on accumulator brake pressure only. Let's see, accumulators, let's make sure I covered everything here I want to cover. Okay, I think that pretty much covers this slide. Let's move on. System number 1 distribution. So what is system number 1 powering and how does it do it? All right. If, and I'll just tell you what, I'm going to go ahead and zoom in here a little bit. You notice that system number 1, we have a rudder, have an elevator, a left aileron, outboard spoilerons, and outboard flight spoilers. Let's move this over so we can see a little more clearly what we're talking about. So we have the rudder right down here showing being powered. Elevator, I'm sure it's going to be powered. See, it's outlined in yellow, saying that it's powered. Of course it would be, because we know that the rudder and elevator both have 3 PDCs, PCDUs, PCDUs on each one. And of course, that means each of the systems, 1, 2, and 3, are powering the rudder and the elevator. The left aileron, not so much. It gets power from 2 systems. Well, for sure, we're going to say that it gets power from the number 1. And I'm just betting it gets power from number 3, as we've discussed earlier. And then we have the outboard spoilerons, which are these guys right down here. There's the outboard spoileron there. There's the outboard spoileron right there. And you'll notice they did not include the inboard spoilerons. They did include outboard ground spoilers right here and here off of system number 1, but the inboard ground spoilers are not included on that system. So what they're saying is they're trying to divide some of these key flight controls amongst the different hydraulic systems, so you have redundancy. So you just don't lose everything if you lose one hydraulic system. And of course, over here, it shows that we have the left reverser, thrust reverser down here. So simply giving you reverse thrust, slow the aircraft down more rapidly, deaccelerate when you've landed on the runway. Okay, let's see what the rest of the slide has to say. Okay, there again, left thrust reverser, left and right outboard ground spoilers. So it goes through the whole thing. And in this case, they're showing in the schematic that the ACMP 1B is the power source. It may be that you are have lost your engine. If you've lost your engine, you have no ability now to drive the EDP number 1A. So maybe that's what they're showing here. I'm not quite sure. Let's take a look at the switches. This is the hydraulic panel that is located in the aircraft overhead panel on the flight deck. What they're showing basically here looks to me like the engines are not running, is what it amounts to. So to get hydraulic power, they've just went ahead and turned the hydraulic pump onto the on position so that it's now powered electrically for the hydraulic system number. These are in auto on, but if you're not providing power to it, let's see, it's hard to tell here on this drawing how they've got this set up, but it appears that they've got the system number 3 powered. It looks like it's in dark green. Hard to tell. Not going to make that assumption just yet. But anyway, so this switch in the on position is going to power the electric pump on the number 1 hydraulic system. So as you can see, this is the number 1 pump switch. Over here is the number 2 pump switch, and these are your 3 pump switches. So just think of these as being electrical switches. These are not pump switches, they're electric pump switches. And there's 4 of them, and you have 4 electric pumps in the hydraulic system and 2 additional engine-driven pumps. Okay, likewise, system distribution number 2, you have the rudder is powered, the elevator is powered, aileron right side is powered, and left and right main landing gear and nose landing gear assist actuators. What those are, they're assist actuators in case you have to free fall the gear. Then you turn this pump on and would help push those gear into the down and lock position. That doesn't actually raise or lower the gear, just pushes them in to the lock position. You have the left and right outboard brakes. Okay, as you can see over here, outboard brakes. Get that right there. Left and right outboard brakes. There's your assist cylinders right there on a free fall when you drop the gear manually. And then you have 1B spoiler on, and that's the inboard spoilers now. Last slide, it was the outboard spoilers, and the reverse, right reverse thrust shown over here. And again, we have the number 1 switch, actually the number 2 electric hydraulic pump switch turned on here, and that shows that we are powering the electric pump compared to the engine powering the engine-driven pump. So that's how they're depicting that. All right, let's move on. System number 3. How could we have guessed? We've done system number 1, number 2. So now we have system number 3. And remember, system number 3 does not have an engine-driven fuel pump. So system number 3, of course, the rudder and elevator. So system number 1, 2, and 3 all control the rudder and elevator. They all have inputs in case you lose 1 or 2 hydraulic systems. You'll always have a backup somewhere if you've got a third one operating. You have left and right ailerons. So before system number 1 and number 2 only operated their respective aileron. And in this case, number 3 is a backup to both. So that's why it works that way. Landing gear, so system number 3 operates your landing gear actuators, can raise and lower the gear. with the landing gear. The left and right outboard brakes are also powered by the number 3 system, and the inboard ground spoilers and nose wheel steering are powered by the number 3 system. So pretty straightforward. And you can get the number 3 system powered up using the backup pump if you indeed want to just turn the pump on. And this is a 3B right here. It says 3B. So that's the switch for this pump right there. Okay. So you turn it on, you power up that pump, and you'll have hydraulic pump pressure to all of these items. All right, moving on. Air-driven generator power. So that's that little ADG is what we call it. That's the little generator that pops out on the side of the aircraft when you lose all normal sources of AC power. Normal sources would be, of course, the engine-driven generator, 1 or 2, and let's say you probably didn't have the APU running. So at that point in time, the ADG is going to drop out the side of the aircraft automatically, or manually if you want to deploy it manually. Not sure why you would if it was going to deploy automatically. I guess if it didn't deploy automatically and you needed it, that's the time you do it. Otherwise, you don't really want it out if you're getting any other source of electrical power or AC electrical power. So again, if there's a total loss of AC power, the ADG will automatically deploy. The ADG will provide electrical power to AC pump MP number 3B. So what we're talking about is system number 3. It's going to power your backup electric pump on system number 3. Okay, so if you had both engines running, and in this scenario, it's showing that you do. Tell you what, I'll just jump right in here a little closer. So what it's saying is if you turned the number 3 pump on, or if the ADG was powering it, say you lost your 3A pump, you could manually turn your pump on. 3B, see it there. You could turn it on manually. If you had an indication that you had lost your number 3 primary pump, you turn your backup pump on, and you would continue to power anything on the number 3 system normally, which then you would regain nose wheel steering, landing gear, inboard ground spoilers, etc. So that all looks good. Looks like to me they're showing 0 PSI pressure in systems number 1 and 2. So if there was no system in pressure 1 or 2, and yet you had system number 3, system number 3 would power the rudder, elevator, left and right ailerons, which means you really don't even need system pumps in number 1 or 2 to be operating. You at least have your primary flight controls and inbound ground spoilers, all the stuff you'd really like to have when you're landing. So, and of course, in flight. And there's our switch again. Okay, ACMP number 1 and ACMP number 2. AC bus number 2 provides power to ACMP number 1B. So if you remember the electrical system, we had 2 primary buses that came off that generally got its power from each of the main engines respectively, normally when you're in flight. The APU can also power bus number 1 and bus number 2. But normally you would not have the AP running in flight unless for some reason you had lost engine number 1 or engine number 2, and you want to make sure that bus was powered from a separate electrical source. So at any rate, you're going to cross power these buses. So this is what the schematic shows. So you notice that AC bus number 2 would normally be in the electrical schematic was located up here somewhere. You had the engine driven pump up here, or the engine driven generator up here. And then this would be bus number 1, driven by normally engine generator number 1. And what they're saying here is they are crossing this over to power that bus and crossing this bus over to power this pump. I meant to say pump over here. So what they're really doing is they're crossing the sources of electrical power to your backup pumps, just in case you lose an engine on one side or the other. So for example, let's say I lost engine number 1. I would end up losing my mechanical pump. Well, if I lost engine number 1, I probably lost generator number 1, which powers, in this case, bus number 2 or bus number 1. So that's not going to be able to provide, if I've lost this, I'm not going to be able to provide power to my backup electrical pump here. So to keep that from happening, they cross power these things, and that adds some redundancy to the system. So we can therefore keep our hydraulic system on a dead engine generator and dead engine pump, continue to power that backup electric pump on the hydraulics. Hope that makes sense. Okay. So we had another little note here. AC bus 1 must be powered for hydraulic pump 2B operation, and AC bus number 2 must be powered for hydraulic pump 1B. We've said that, just restating it, I guess, another way. Okay, this is important. ACMPs 1B and 2B do not automatically start during or after an engine failure. So what the QRH is going to tell you to do, the quick reference handbook, somewhere in its engine failure procedures, it's going to tell you to come up and manually turn one or the other of these pumps on. So if you lost, say for example, you lost engine number 1, it's probably going to tell you to go ahead and turn this switch on, which is where then it would get power from the AC bus. Or correction, let me get rid of that line. That's not going to work for us. It's going to end up powering the bus from AC bus number 2. So that's what the QRH is probably going to tell you. I'm quite certain of that. So keep that in mind when you're looking through this as to why we have the redundancy set up the way we do. And remember, you're not expected to necessarily memorize all this stuff, because in an emergency situation where you have a failure, in most cases, you're probably going to go ahead and get your QRH out, quick reference handbook, and read and do what it tells you to do, so you don't make a mistake and make the event even worse than it has to be. So. Engine fire SOV versus hydraulic SOV. When the engine fire switch is pushed, multiple valves and associated systems associated with that engine are closed, or components are disconnected, and the engine will shut down. The hydraulic SOV will automatically close to restrict the flow of hydraulics to that engine. Let me get rid of some stuff here. I guess that little circle I drew in prior to this, apparently for some reason. So let me reread this. When the engine fire switch is pushed, multiple valves and systems associated with that engine are closed. So if you lose an engine, you have an engine fire, you're going to push the engine fire switch and close off a bunch of stuff going to that engine, such as fuel, for example. You'd want to shut that off. You're also going to shut off the hydraulics. That'll be one of the other systems that gets shut down. And the hydraulic SOV will automatically close to restrict the flow of hydraulic fluid to the engine. That's when you push that button. That's what's going to happen. Automatically going to happen. Where's the engine fire switch? Here's the engine fire switch right here. So you push that button, and these valves in the hydraulic system are going to close. We saw them in a little different location on the schematic, but it's going to close. So they're saying you may have closed, this engine may have been on fire, so you've closed that valve. Engine fire SOV continued. Okay, in the event that something less dramatic occurs. So let's say you don't have an engine fire, but you'd like to shut the hydraulic valve anyway. In the event that something less dramatic occurs, example, high hydraulic oil temperature, which would be enunciated on your ICAS right up in here, something like that may occur. An alternate method of closing the same hydraulic SOV is accomplished using the hydraulic panel. Now, the hydraulic panel is different than the hydraulic switch panel, and it's different than the fire switch, fire engine button. So it just is going to do one thing, and it's going to close the hydraulic valve when you select it closed. So in this case, the hydraulic panel allows closing just the selected right or left hydraulic SOV without affecting all of the other engine-related systems because of shutting down the engine with the engine fire switch. But we don't want to shut down the engine fire switch, the engine using the fire switch, because we don't have a fire. So if we just had a high oil temperature in the hydraulic system, we would then go ahead and just push this switch right here. And this is the hydraulic panel. It's on the overhead panel. You push that and just close the valve. And then this engine here would just keep running normally. So not a big loss because there's nothing on this system that we have to have powered in order to safely fly the aircraft. We can safely fly the aircraft with everything that we have on these other two systems. No big deal, not a threat at all to the safety of the flight, other than we probably want to start thinking about a place to land just in case we were getting ready to lose some other system. So what we do is we just simply follow what the QRH said, and we'd follow it, a read and do type of checklist. Normal pressure provided by each hydraulic system is 3,000 pounds plus or minus 200 psi. When the pressure drops below 1,800 psi on any system, a low pressure caution message is generated. So normal pressure is 3,000 plus or minus 200. It can drop down to 2,000. We're not going to get an alert, but once it goes down below 1,800 psi, then we're going to get an alert right up in this area of our number one ICAS panel, and it's going to say, hey, hydraulic number one got low pressure. Then we'd know to go to our synoptics page for hydraulics, and we could take a look at it, and we'd say, oh, I see, the pressure is already down to 0. We have an issue with this system. So we would get our QRH out, follow the instructions on the QRH for hydraulic number one low pressure. It might say hydraulic 1/2, giving you your choice, but it's going to be the same QRH. And we're going to follow the instructions on what to do. Hydraulic fluid cooling. So this is kind of an interesting system. We want to keep this fluid relatively cool. We don't want it to overheat. That could damage components, O-rings, that type of stuff. So we try to keep it cool. Hydraulic systems 1 and 2 fluids are cooled by ram air heat, a ram air heat exchanger, and by running the hydraulic plumbing lines through the fuel tanks. So in this case, what we're showing here is that on hydraulic system number 1, you have that ram air. So fluid is going through a heat exchanger here, getting cooled down, and then being returned, but it might be getting returned to the fuel tank system and following on around, comes out, and so forth. And now it's doubly cooled. Why would we want to have it doubly cool? Well, because these are engine-driven fuel pumps, and those are our primary pumps. We definitely want to keep that system as cool as we can. It may be that those pumps have a tendency to overheat and heat up the hydraulic fluid. So just a good way to keep it cool. So same thing goes with system number 2. It's engine driven, but we're going to keep it cooled down again through a ram air heat exchanger and radiantly cooling through the fuel tanks. That's a little different than system number 3. System number 3, we do not run through the ram air heat exchanger. There is no ram air heat exchanger for system number 3. It is simply cooled down by directing fluid through the different tanks, fuel tanks, to get it to cool down. Obviously, they don't have a situation where they have a serious problem with overheating the fluid in system number 3. Not sure why, just the way the engineers have designed the aircraft. Hydraulic fluid temperature. Temperature of the hydraulic reservoir fluid is shown in green on the hydraulic synoptics page when the temperature is less than 96 degrees. So less than 96 degrees, they consider to be normal temperature. When it rises above 96 degrees, then we get an amber alert. Amber alerts, of course, amber or magenta alerts are alerts that we go to the QRH and read to see what we need to accomplish. So as you can see here, temperature is shown here at 97 degrees in amber, and we would have gotten this alert on ICAS number 1. This is the synoptics page for the hydraulics, and that's where we can see this information. Exam question number, well, this is just another possible exam question. Which hydraulic systems provide power to the flap actuators? Okay, so I'll tell you right now, that's a trick question, but I'm not going to tell you what the answer is. Again, you need to go back, make sure you understand the systems. That's a trick question. Which hydraulic system provides power to the flap actuators? Good question. Stumps a lot of people. Had me stumped for a little while. After I got to thinking about it, I'm going, oh, well, no wonder. And then I came up with the answer, and it was pretty embarrassing when I finally thought about it. I'm going, geez, why wouldn't I have known that? Well, because I've flown a whole bunch of different airplanes, and I just assumed some things that were not actually true for the CRJ 700. So that's a good question. It might be on an exam. So in the meantime, that's the hydraulic system. Not all that complicated. There's three systems on the aircraft for redundancy. They work on a total of 6 different pumps. 2 of those pumps happen to be driven by the engines. The rest of them, all the other 4, are electrically driven. They are cross-wired in some degree for redundancy purposes. And that's a pretty basic summary of the hydraulic system. And everything is pretty well powered by at least 2 hydraulic systems. In some cases, some components of the flight control systems are powered by all 3, just as further redundancy. So go to your module, hydraulics, in your in your Aerosim program. Review hydraulics, just like you've been doing with every other system we've covered. Get on through, go right down to the last page, answer those questions at the end of the module, and then don't forget, you want to sync up make sure I got the information that you did cover that module on your own at your own pace. It's just going to be a redundancy, a little bit more detailed information than I've given you here today. But don't forget, when you're done looking at it, sync it up so I see it. And until then, I love my job. Glad to be here. Hope I can make a difference.